Hello everyone, thank you for coming and having a quick lunch. Okay, I'm Juan Pablo. I'm one of the GUADEC developers, but this time I'll be talking about a new thing I've been working on while working for Endless. And it's a tiny library that lets you embed GTK widgets in a web view of WebKit 2. Okay, so what do you do if you need to embed a WebKit? If you need to embed a GTK widget in WebKit, this library will let you do that, and it's a proof of concept, but it's already working, and we are using it in some production application. So what's the use case for this? In our case, we wanted to reutilize the GTK component that we had, and the actual example was we have some applications that are made to display content, and the articles we display are of course displayed using a web view because they are HTML articles. So we have this component that's a related article, so you can go through different articles that are related to the main one, and that's implemented in GTK, but the user experience wasn't really good because with GTK, with WebKit 2, since there's no way to embed the widgets in the article itself, what we did was basically trigger a popover that will be triggered by scrolling the article to the end. But that doesn't work too well. It's kind of confusing for the users when something pop-ups out of nowhere. So the ideal case is to embed that component inside the article itself, so that you don't have to maintain two different implementations, one in GTK and one in HTML. So this is how one of the applications look like. Here you can see in red, that's a web view with a regular HTML inside. And this is how the popover used to look like. And that was basically triggered when you scroll down to the end of the article. And this is how it looks in a development version with embedding the actual widget inside the web view. Okay, so why is it called Maxwell? As you can probably know, naming things, new things, is one of the hardest things, at least for me. So I wanted to have something that's easy to remember. This project was inspired by the Broadway backend of GTK, which is a backend like X11 or Wayland that lets you run any GTK application in a browser. So, and the Broadway backend was named after the X11 Broadway release, which one of their feature was called X Asian 96, that reminded me to Asian 86, which is Maxwell Smart. So that's why we call it Maxwell. Okay, so how does it work? First of all, I want to say I'm not a WebKit hacker. I have no knowledge of the internals. So what I wanted to do was basically try to implement this idea I had using only public API. So one of the biggest problems where I think why it's difficult to embed a GTK widget in WebKit is because WebKit 2 uses a split process model. So they split things in different processes where you have the main thread where the UI runs, And then you have two extra processes that are launched by WebKit. One is the web process, where all the web core things are run, JavaScript and other things, and then you have a different process for all the network related things. So to embed a widget, what do we do? What do we need? We basically need two main things. One is a way to display the widget inside the DOM tree. So that's basically two things. One, a way to get the image inside the DOM tree, and a way for the DOM tree to adapt to the actual widget, so that text will wrap around it and things like that, that you will expect for a regular HTML element. And the other big part is how to handle the input events properly, how to get the events either from WebKit and pass them to the actual widget that you're embedding, or catch the events before they get to the web view. So, inspired by the Broadway backend, I had an idea, and I thought that if I had all the children's that you add to a web view rendered to an off-screen window, then it will be possible to get that image data and render it into a canvas element inside the DOM tree. Okay, so one of the key features I use from the WebKit API is a function that lets you run any arbitrary JavaScript code inside the JavaScript VM of the web view. It's pretty straightforward. So one of the things, if we wanted to use a canvas element, would be we need to keep synchronize the size of the widget with the size of the canvas element, and that would be done quite easily by running some JavaScript to set the width and height of the widget. So every time the size of a widget changes, I run some JavaScript to make the change in the canvas element. So the other, and that will basically cover all the interaction in the DOM tree. Since it's a regular HTML element, all the other like text and everything will just wrap up and work exactly as you would expect. So the next big thing will be how to get the image data from the widget that we had in the off-screen window into the actual canvas element. The first really rough implementation, I guess you could basically, since you can run any JavaScript code, you could get the buffer data and serialize it to JavaScript array and then use that, but that obviously would be too slow. So thankfully, WebKit lets you register a custom URI scheme. So every time you can define any arbitrary new URI, and every time there's a request for that URI, WebKit will call a callback for you, so you can actually implement it and basically return any data you want to the JavaScript. So that's what I did. I created a Maxwell custom URI. So from the JavaScript side, all you have to do is create a new request with a widget ID that you want to get the data from. One very important thing is to set the type to array buffer, so there's no weird conversion between JavaScript arrays and binary format. And once you have that, once you get that data back, all you have to do is wrap that data into an array, and then you can use regular Canvas API to actually draw the image. So, what's going on behind the scenes? This is a simplified version of what's going on, because WebKit has more than one process, but I'm just gonna split things into the main process where the UI and GTK is running, and everything that runs on WebKit. So you get a draw from a widget that causes a damage event. When I have a handler, a special handler in the damage event that calls a JavaScript function that basically is for drawing the widget that will get the image data using the special URI we just talked about. That will get them the data, then the WebKit will call in the URI special custom URI handler, which the current implementation grabs the off-screen data using converting it into a GTK pixpath, which then it's used as the source for a memory IO stream. That's how the handler are implemented, and that's how the WebKit network process reads from the memory. So it's gonna read using that stream, and then, like I showed in the previous example, that's turned into an image data where you can use it with good image data function. So that will be for how to get data, image data inside the web view. The other part is how to properly handle input events. My first attempt was to actually use to listen to events in the DOM element and then marshal them back to the application. But then I remember that GTK actually has a nice way to get events before they reach the web view. So there's one special method that you can implement that's called big embedded child. That's basically something that GTK runs before sending events to the widget, so that it can decide for which off-screen widget the event should be dispatched. So to know to which widget I should send the event to, what I really need to know is the position relative to the web view viewport, and that's calculated using JavaScript. There's really no good way to do it in a performant way. So what you have to do is call this function, getBounding client rec, which basically calculates the position of the element by iterating over all the, going up the hierarchy of the DOM tree. But the thing is, you have to call that function every time there's a scroll or a resize event, or even every time there's something in the DOM tree that changes. For example, if you add an element that has more text or things like that, then you have to recalculate. But hopefully there's some new specs that eventually will be implemented, so there will be a way to actually listen to position and size changes of every element using some new mutation observer. But that's still a draft and it's not implemented yet in WebKit. But hopefully we'll get a better way to do that. Okay, so about the API, what I tried to do was use as much, to make it as tiny as possible and use as much common interfaces as possible. So I come up with something that's really simple for the application developer. All you have to do is create a Maxwell web view, which derives from the regular WebKit web view. Then you create your own widget that wants to embed in it. All you have to do is set a name to that widget, and then you can add it directly to the web view using regular GTK container interface. And the only special thing that you need to do, we need a way to tell where we want that widget in the DOM tree. And all you have to do is create an element, a canvas element with a special class called GTK widget, and the ID that you set the name of the widget. Okay, so I guess it's demo time. Okay, so this is a tiny example that I used to develop Maxwell. As you can see, I'll show you. It's a web view, and that is actually a GTK widget. You can see there's a button, labels, and entry. And they resize and wrap around the DOM tree as if they were regular HTML elements. And one nice thing is that you can even use CSS to change the looks of the widget, and that works quite well. So, I don't know, let's say and there you go. Okay, so for example, I connected this entry activate signal to load a new page when you type it in. So for example, we can go to the GUADEC website. Okay, now I'm gonna show you a real world application. So this is an application that's meant for to display news articles. So you have categories and things like that, and if you go to an article, that's actually a web view. And at the end here, you'll see the GTK component for related content. Okay, so to build this tiny library, it's in GitHub under endless account. All you have to do is like any other regular Meson project, and that's it basically. So what's next? I have a few ideas to optimize even further, because right now there's a lot of copy involved every time a widget changes, which is I guess faster than the Broadway backend. So for regular widget uses, it's pretty good. But if you want to embed a widget that displays some animations or a video, then things get more complicated because it takes a lot of memory bandwidth. Because you can imagine that you are rendering to an off-screen window, which basically resides in X server memory. So then the main thread gets the memory converts the memory to a pixbox. So there you have one copy. Then that's copied to the network process, another copy, and that probably gets copied again to the web core, and then back again to the main thread to actually display. So one idea I have is try to use the texture from Pixmap extension so that I can export the actual off-screen content as a texture and use it directly with WebGL. But I haven't looked into too much into it, and that's probably gonna need some work on WebKit itself, maybe to expose the GL context or something like that. But yeah, eventually, once I have some time to work on it, I'd like to give that a try. If anyone knows if this is possible or not, please let me know. Yeah, and another thing, eventually if someone finds this interesting in using it, maybe it would be a nice thing to propose it upstream. Probably not as something that we will add directly to the regular web view, but maybe add a new class specifically for this purpose. Okay, thank you.